Hey, welcome back to Engineer's Workshop. So it's after Thanksgiving. It's got that time period between Thanksgiving and Christmas that just seems to go by like that, but trying to get done a little bit of this and that in the shop. Got the abrasive number 1.5 surface grinder that I've been pecking away at. Any parts that come off of that, I'm going ahead and cleaning and painting. I'm going to start putting together the little gearbox that moves the lower table back and forth. You can see I painted the wheel guard, cleaned that up. So little by little, this thing's coming back together, getting condensation on the steel surfaces. I don't have a heat light in this. I really need to rig up another heat lamp like I've got in the Cincinnati, and I got two in the K&T to keep the casting warm. And then that way this thing won't sweat when it gets cold. I don't know how I'm going to do that with the lathe. The lathe is going to be a difficult thing to heat up. There's really no, I mean, I guess I could get something maybe under the headstock foot and get the headstock area heated up on that, but got to do something. I want to protect this as I'm redoing it. And you can see I got the lift over there with the little yellow light on top, shoehorned in between my inspection table and the compressor. I'm going to start work on getting the vertical lines going up to the ceiling. The determining factor for that, for the elevation of my horizontal conduit run, is how many fixed sections of 1-inch Schedule 40 pipe I can get up to make the right hand bend. And as one of my viewers pointed out, that with that lift I can get high anytime I want. So I'm going to get high later on in this video and do a little bit of startup work on that. Also, I'm going to do a little project, a quick one, for the centers for the Cincinnati Tool Cutter grinder. I was showing through those things on another video, and you can get blinders on from the way things maybe you think are supposed to go together. And two viewers caught something that I didn't, and caused me to go in another direction on getting the Quill clamps on that thing. So I'll get a little bit more into that over at the whiteboard. Let's go over and start with that and just kind of filter in mishmash with other things as I work on them. So I wanted to show you how you can get blinders on when you see one way of doing something and can't visualize another way of doing something. This is the tailstock of my Monarch lathe, and it has a 4-inch quill. And then to lock the quill, it has a bore in the top of this casting that's about a 2-inch diameter, and that ends, it's a blind hole there, and at the bottom of the hole it has a threaded hole, and there's a stud that sticks up, and the plug that goes in this is shaped to fit the scallop of the 4-inch quill. Looks like that. It just has a hole in it. Now this thing was really stuck. If you look at, let me section this. This plug and the quill were really stuck when I got the lathe. In order to get that plug out, the trick I did was I took out the stud, I packed grease into this cavity and up into here, and then I made a closely fitting piston, a rod, and then I hammered it down. Felt like you're hammering steel on steel. And the pressure spikes that were created by the hammering of the grease, which is incompressible, drove this plug up. And I had to keep adding more grease because the area I was displacing was less than the area pushing on the underside of this plug. But it finally got the plug up to a point where it was exposed, and when I could get it, I could start to wiggle it and turn it. Finally came out. And then I got the quill out. So my thinking this entire time on locking quills into a bore was predicated on how the Monarch was done. So in comes the centers for the Cincinnati Tool Cutter grinder. Now there you've got like an 1.5 inch diameter quill, and the little plug that locks it is a 5/8 diameter. But this passage goes all the way through. And then that plug is in here like this. Plug actually sits below the surface, and it has a clearance hole inside for a 1/4" screw. Nothing on the underside. And I'm thinking, well, it has to be able to pull up on something, so I imagined I was missing some sort of like a T-nut that bottomed on the underside of this casting, and the threads were in that T-nut, and that's what I was going to reproduce. But, don't know why that's not erasing nice. Two viewers pointed out something to me, Brian Block and Ed Callahan, and they both said, well, wasn't there possibly another plug on the underside of this that had the threads in it? And this actually pinched the quill from the top and the bottom. And that's when, the light bulb goes on. Of course, that's what it is. So I am now going to make this lower plug. Let's go over and show you the material I have to do it. So here's my center, and the quill was also stuck, and I had to get that free. And this was a 5/8 diameter bore in here for the quill lock, and I have my piece of McMaster 5/8 drill rod, which is a very nice fit in there. And I previously had purchased a 3-inch threaded lock knob, which is a pretty close match to the ones that are on there. And this was the plug that was stuck in the top, and you'll notice that instead of a scallop, this just has a diagonal chop on it to lock against the OD. And if you get in real close here and look, I don't know if you can see, but it's contacting up here, and there's a point of, there's evidence of line contact along that. Well, what I'm going to do is I'm going to use the DRO of the tool and cutter grinder, and I'm going to establish the center line of that quill, and I'm going to establish the center line of these by measuring the inside edge and then using the diameter. That'll give me the relative offset of these two pieces. I'll model it in CAD, and then for the underside piece, I can do a little bit better than a scallop. I have the perfect machine to make a mating, actually a radius cut that will nest against the side of that quill, and that is the K&T rotary head mill. So let's take some measurements and get set up to machine this drill rod. I set up the indicator and I trammed this. I had previously zeroed the table over a pretty good distance with the vernier, but I'm reading a little bit of just local undulations here, a couple thousandths back and forth, but it's returning to the same spot each time. So I think because there was a center clamped in this location, I have a little bit of wear right there. And we need to check our starting diameters here. The quill is 1.5 on the nose, maybe not even a 1/2 thousandths under, about a 1/2 thousandths under. And the stud is 0.625, also a 1/2 thousandths under. So now I need to set up to read the back side of the quill, and with that I'm going to use an indicator and the DRO of the in and out, I guess you'd call it the y-axis travel of the machine. I know at this point the indicator is above center, so I'm going to come in until I touch, and then I'm going to lower the head until I get a high reading. I might have to back off here a little bit. Still climbing, still climbing. There's my high point. Let's get on that high point right there. And we'll turn on the DRO. As a double check, I'm taking my DRO and I am going to move it, and I'm going to bring the indicator back to 0, which you can't see on camera, and see how close the DRO gets to its 0. Now I'm using a half thousandths resolution indicator and a tenths resolution DRO. So let's see how good I can get. I'm not watching the DRO, I'm just trying to get that needle back on 0. That's it right there. So I'm about 3 thousandths off from the DRO. There I'm 2/10. So that's the direction I need to come at it. So let's go ahead and 0 this. Now, without moving the table, what I need to do is to reposition the indicator to be able to read the vertical stem of the quill lock and bring the table back until my indicator reads 0, and that will be the amount of travel that the table did, differences between the two axes. It's not obvious to look at, but basically what I have to have is a orientation of the indicator stem that's going to work both with the horizontal position of the quill and the vertical position of the stem here. So without moving the table in or out, I'm going to raise the grinding head, which raises the indicator stem. But my 0 position is remembered by the by this indicator, as long as I don't move it. I need to come up to where the indicator is above the casting. Move this way. Now I need to crank the table in, and I will watch this indicator when this stem touches the back side. There we go. Now roll this back and forth, find the high spot. Right there. And bring it on to 0. Make sure we peak at 0, and we do. And we can see that our DRO is reading 1.3675. So we can take that dimension plus the diameters of the quill and the actual quill stop, and we'll go over to the CAD machine, to SolidWorks, and we'll model that, and then we'll know what the actual geometry of this quill stop is. I modeled the quill, which is the 1.5" diameter circle here, and the little quill lock, this is the rectangle, and that has a diagonal chop right here, so you can see where it makes contact with the quill, and it stops just above center line. So if I duplicated that geometry with another cylinder and that same diagonal chop, they would never touch, which is what we want. But like I said before, I can improve on this design by putting an arc in here with the K&T rotary head mill, and then that will nest along that entire surface, and it would serve the same purpose. And to do that, I would have to have an offset of 0.930 from one center to the other, and a vertical height of 0.0723 to place that arc in the same place of where that stops now. But what I'm going to do is I'm going to take the opportunity to change one more thing. As it is right now, this little quill lock drops below the surface of the actual casting, and that requires that the T-nut up here dip into the bore. And unfortunately, the T-nut is the same diameter. It's, 0.625, and it's rough and it's plated, and I would have to take a cut on that T-nut, that thumb wheel, if I were to leave this alone. So what I'd like to do is make this upper piece sit up a little higher, and what I did was I just dropped the center line of the actual quill piece relative to the original position. And so instead of a 0.0723, I offset an 1/8 inch. What that's going to do is effectively make this sit a little higher in its bore. And I'm going to swing this scallop, which has an offset of 0.1973, and it's going to be a slightly smaller scallop, but it'll force this cylinder sit up a little higher in the bore and hopefully be proud of the surface of the casting. So this is what I'll set up in the mill, make a little bit smaller scallop on the original pieces, and I'll make a mating lower threaded quill stop piece that's going to sit on the underside to match. Well, let's see how much damage we can do with our new toy. Once I load all my tools in here, not a lot of room to maneuver. Okay, outlet works. Forgot to turn on my light. Here's a point here where my air line comes up from the compressor, and I made the provision for it to go vertical and also horizontal, although I think we're going to always maintain a doorway there. I need to take this plug out. And I believe my 10-foot piece of black pipe is too long. Yeah, I'm basically up into the, let me see if I can show you. That basically goes right up into the eave. So I'm going to have to go with a 60-inch and a 48-inch. And then looks like that'll be about perfect. Try to get in just a little closer here. I don't think there's anything in my way if I just go straight. Nice thing about pipe joints is you can just start at the top and tighten everything at once. Let's go up a little higher. I think I'm going to get a smaller pipe wrench next time to do the bulk of this tightening. The 24-inch one is heavy. Well, there's about ½ inch of sawdust on this second girt. I think that's reasonably tight. We can take a measurement now from the underside of that pipe to the concrete, and we use that measurement as a basis for how long we make the hangers. 199 1/4. So if we go over to this side, I'm going to measure on this purlin up here what the distance to the underside of that purlin is. 210 1/2. So 199 1/4 to 210 1/2. 12-inch hangers ought to do it. And let's go 12 1/2. using the air pipe to establish the level of this first member. And then my strategy is going to be get this point level with the upright, the elbow, level it across, and take a measurement from the unistrut to the underside of the purlin. I'm going to go over to the opposite side of the building. Actually, I'm going to attach a string here first. Go over to the opposite side of the building, put the corresponding other hanger on the far side with the string stretched between them, and then I can just bring the others up to the underside of that string. So hopefully that will work out pretty nicely. I've got to shorten this up just a bit. Okay, so I've got my 1-inch conduit, which is going to be for the sub panel. It's 3 heavy copper conductors, neutral and ground. Then I've got 2, which I'm going to use as lighting circuits, and they're going to, one of them is going to end at this next purlin and then go left and right. So hopefully that can, yeah, I think I got to go back just a little bit with these anyway, but one of these will branch out in the conduit left and right. I'm going to have 1 circuit per bay per side, probably 2 lights per bay. It's, you know, every 12.5 feet I'll have a light. And that'll hold a lot of, 3/4 inch conduit will hold a lot of 14 gauge wires. I think the count is 22. So that's enough for all my circuits. For each side of the building. I'll have 2 gangs of 5 switches on the panel down below, which these 2 are going to go to, and that will wrap it up. I just got to get the down pipes from these down into the switch boxes and to the other panel, and then I can continue working my way across the building. Take this down on one of my trips up here. I finally found a use for this steel structure in the yard here. I don't know what this was. There is an electrical conduit coming up underground here from inside the building. It was some kind of conveying equipment. There's more foundation here, and it was taken up. But when you're bending conduit, and you're doing a Z-bend, pardon the grace of me getting up here, you always end up with one end of the conduit that is sticking towards the ground. So with this, I can hang that over the edge, and I could complete my Z-bend if I can balance on this thing. That's going to be the second trick. And of course I've got to do this in the 1-inch conduit, which is the hardest. Let's just get ready and go for it. Looks reasonable. We'll put it up there and see how we did. Okay, I'm over at the far side of the building, and I have the corresponding hanger done at this is 5 feet from the end of the building. I'm just looking at all of the sawdust and everything that's on top of those girts over there. And I got to get all that off somehow without dropping it on everything below. Fair amount of sawdust here on the bottom of the beam too. That's just holding moisture, no sense in leaving that. So what I did was I strung some mason's twine across, and I don't know if you could see it to sight it, but there's probably, I don't know, 1/4 to a 1/2 inch sag in that, which is about as good as I can get. But what I'm going to do, starting with this girt here, measure vertically from the underside of the girt to the string, and do that at 2 more locations across, and then I'll pre-make the hangers and set up the washer stack so that the hangers are the right distance from the the end of the threaded rods. That way, as I move the lift back across the shop, I can put those hangers up just touching the underside of the string. Might lift the center of the string up that 1/2 inch or so, but that's how we'll get these 5 hangers across here straight. Well, I hope you enjoyed that. Gotta admit, I'm absolutely loving my lift. I don't know how I did without it up until this point. Of course, that's what you always say when you get something new and it's a useful tool. So we'll be making a lot of use of it in the next couple weeks, getting this run here, this main run, holding 3 conduits to bring power over to this side of the building and air over to this side of the building. And then, I've got 2 lengths here, which would be on, that's this purlin on the ceiling. I'm going to have the overhead panel lights. And those are going to be like crossing. So in other words, this one will be aimed down at the 3/4 point of the building there. Then on the far side, that'll be aimed down, illuminating this side of the building. I think that'll give a pretty good uniform coverage. Have 2 panels per bay, and that's the really bright flat panels. I think they're about 20,000 lumens from Amazon each. So once we get 2, 4, 6, 8, 10, 20 of those in this building, it'll be very bright in here. So that's all for Engineer's Workshop. We'll pick up on the little quill locks next week. Do those up, 'cause now that I've got the geometry laid out in CAD, I'll take care of that on the mill. Should be pretty quick, and continue on the abrasive 1.5 surface grinder. So thanks again for watching and subscribing. Christmas is coming. Hope you guys have a great holiday season. Merry Christmas and Happy New Year to everybody. And that's all for now. As usual from Engineer's Workshop, stay safe.